Good evening, friends. Welcome back to Domain Analytics program, and we are looking into education data analytics. So we have seen the type of data that we are going to have here. We have looked into different applications. So what kind of data we are going to have here? So we have data related to universities. We have data related to institutions, exams, trainings, government organizations. So basically, we have this type of data that we are going to look into. So when it comes to education data analytics, so what we are going to have? So what type of data we are going to have here? So we are going to have universities, exams, trainings, government organizations. So these are the different sources that you can see. From here, we are going to get the data. And when it comes to applications, when we look into the applications here, so there are different models that can be developed. Like by using the education data, we can develop learning analytics, learning management systems. So there are many tools that can be developed by using education data. So this is all part of education data analytics. So apart from this, when we look into the applications, okay, when we have seen the applications, so when we see the applications of education data analytics, what do we have? There are many applications of that. So one application could be performance management. So it could be the performance of the student or the trainer. So we can record either the performance of the student or the trainer. Or we can use the data for some standard management. Okay, for some standard measurement. So these standards, okay, there are certain standards that should be maintained by universities or institutions, schools, or training centers. So these are certain things that should be followed by these. So we can measure the different standards here. So we can use this data for standard measurement. Or we can also use for research performance, or to discover best practices, discover best practices, or we can use for crafting better curriculum. Always we can make certain changes in the curriculum, so we can look into the best things and we can bring into the new curriculum. So these are all like we can do the career prediction. We can use this data analytics and career prediction. We can also use in personalized tuitions, and we can apply in matching mentors. There are many several applications that we can see, and in the overall increasing revenue of these universities, maybe participatory teaching, we can introduce participatory teaching. So apart from this, developing different learning management systems. So these are all very important, and nowadays, based on the online education also, so these tools are playing very important role. So the education data analytics. So how do we analyze the education data? So these are playing very important. So today we are going to look into project management methodology. Project management methodology. So what do we have in project management methodology? So here we are going to have, so why do we use a project management methodology? So basically we use the project management methodology for the smooth running of the project. So basically we use the project management methodology for the smooth running of the project. So it is common in any project that we are using. So in the same way, when we work in machine learning process, when we are working with education data analytics, so here we will be looking into a project management methodology called as CRISP MLQ. So what do we have in CRISP MLQ? So CRISP MLQ is cross industry standard process for machine learning applications with quality assurance. Quality assurance. So this is the abbreviation of CRISP MLQ. So basically we have 6 different phases in CRISP MLQ. So today we are going to look into what are the different stages of analytics we have. And along with that, we will be looking into what is CRISP MLQ methodology. So what is inferential statistics, unsupervised and supervised learning, data split, error functions, and overfitting versus underfitting. So what are these conditions? So what are the different stages of analytics? So we have 4 different stages of analytics. So the first stage of analytics is descriptive analytics. So what happens here? So the question that we are going to ask here is, what happened in the data? So we will be asking a question. What happened in the data? So if we take marks of a student, okay. So for if I am taking the marks for 4 different semesters, or we take a department, we have a computer science department. So in computer science department, we will have when we take, if we have like 4 years, in 4 years, so we are looking into evaluation of different students. So we want to see what was the progress of these students. So maybe in the first semester, okay, if you are trying to look into the trend, okay, maybe in the first semester we had some data and we had raise in the data. So we have raised in the data, and then we can see there is a drop in the data, right? So this could go up and this could go down. So we are trying to read the trends in the data. So what happens in descriptive analytics? We try to ask the question, what happened in the data? Why the data has raised here? Why the data has come down? Right? Why? So how the students are performing very well in this period of time. And here we can see that there is a fall in the marks. And again, there is a raise in the marks. And again, there was a fall in the marks. So what was the reason? Right? So maybe like there are many post-COVID analysis have started. So people like 2 years, students were not going to these schools, right? So what happened? There was a performance differences that were noticed. So there was like the observational studies were made on the students. They have noticed certain differences. They have noticed certain fluctuations in this data. So the first question that we are going to ask, what happened in the data? What practically happened in the data? Right? So there is a raise in the data, there is a fall in the data. So these are the different factors that we are going to consider. So once we know what happened in the data, now we look into diagnostic analytics. Now here we try to find out why something has happened. Right? So here the question that we ask in this stage of analysis is, why this has happened? Why there is a upward trend? Why there is a higher trend? Okay. So these are few things that we are going to look into. Then we have the next stage that is called as predictive analytics. So in case of predictive analytics, we will be looking into, now we know what happened in the data. Now we know why it has happened in the data. So the next approach will be what can be done. So what would happen? Okay, what would happen, right? So we are trying to predict something. So this is called as predictive analytics. So this is called as predictive analytics. So once we know what happened, once we know why it has happened, and we have predicted something, so obviously, ultimately, we are going to prescribe something, right? So recently, we have worked on a project where we tried to look into the suicidal tendencies or reasons. Okay, suicidal reasons of students. Okay. So what we have done, so we started the analysis, finding the reasons here. So we have done some textual analysis. So by using this textual analysis, so text mining, okay, we have got certain data. So we looked into different newspaper articles. From these newspaper articles, we try to extract certain amount of data. So once we have extracted this data, now we try to, so if we have a textual data, from this textual data, now we try to find out which words are repeating most. So we have used certain things like prompt vectorizer. So now we have analyzed what is happening. So we have used certain graph representations like word cloud. So where we try to see which words are representing most. Once we have got this, then we went for diagnostic analytics. So what could be the reason? Then we have come with predictive analytics. So finally, we came up with a solution by creating a questionnaire. What we are trying to do here by using this questionnaire. I am trying to predict. Okay, by using the questionnaire, I am trying to predict. Okay, so whether the student would is there any condition that student would lead to suicidal? Does the student have suicidal tendency? Right. So that is something. Okay, there is some factor that we have seen. And what is the prescriptive analytics here? If I find that, so based on my predictive analytics, if I find that if the student may have the suicidal tendency, what we are going to do? So there should be some counselors, right? So they should be counseling the student. So we should have some expert, a psychiatrist. Maybe he could give some help to the students, right? So like maybe students will be very depressed based on their marks. So there will be very many reasons. So there should be some specialist who should be suggesting this. So that could be that is one example that I can look into when we have education data analytics. So along with this, yeah, so we are looking into CRISP MLQ methods. Basically, whatever the stages of data analytics that we have seen, we start with CRISP MLQ methodology. So what do we have here? As I said earlier, so CRISP MLQ stands for cross industry. It stands for cross industry standard process for machine learning applications with quality assurance. So we can see how we have the abbreviation. So we are giving it as CRISP. Okay. So we are giving it as CRISP MLQ. Okay. MLQ. Right? So this is the basic abbreviation that we are seeing here. So it consists of 6 different phases. So first 6 phases are like business and data understanding we have. So data preparation, model building and tuning, model evaluation, deployment, monitoring, and maintenance. So these are the 6 different stages of data analytics. So what are the different cases or use cases where we can use this? When it comes to data science in education field, student assessment data. Like I may have, so if I have a data, I'm going to have input data and I'm going to have output data. So when it comes to student assessment data, so what can we expect here? I am going to have all the subjects here. Right? We can have all the subjects, and based on the subjects, like maybe maths, science, social, English, maybe any other language. Okay. So now, if I have all the subjects here, I can get a aggregate percentage. So I'm going to take these percentages. Based on these percentages, maybe here I have the student name or student ID. Student ID. So what I'm going to do here? So I am going to take all this data. I'm going to take all this data. Based on this data, I have all these percentages. Maybe I can create a page. Okay, I can create a new column called as grading. So I can say that if the students are getting above 50 marks, it is like A grade. If the students are getting below 50 marks, it could be B grade. So whenever I get a new mark, okay, when I get a new mark, a new student, so I am creating a model such a way that automatically my model will grade the students. Okay, it will grade the students. So the grading system in Europe, okay, mostly these uses these machine learning systems. Okay, so where there the general grading system will be different. So what happens if there is a semester? So in semester, if I am having some maths exam, so there the grading will not be for all the subjects. We are not going to get an aggregate grading. So what we are going to get is like, so I am going to get a individual marks, individual grading for each and every subject. They don't believe in aggregate marking or first rank, second rank. So in all European institutions, so this is something will be practiced. Yeah, so that is something will be practiced. So this is something related to student assessment data. So we can take the aggregate from that aggregate, we can create different gradings. Okay. So we can create a model based on that, we can get the analysis. So this is one example. Or so there is a system. Okay, for example, there is a system that we have created where we are looking into number of hours student prepare, right? So maybe this is my input data, this is X, and when it comes to my Y here, output data, student marks, right? So what happens generally? So we are going to see like how these are related to each other. Number of hours a student prepared and marks. So when I look into the analysis here, so if the number of hours increased like 5, 10, 15, 20 and 25, and here we are giving marks 20, 40, 60 and 80, and if you go further 100. So we are seeing that students who have prepared for more hours, so definitely they are getting more marks, right? So these values are correlated to each other. So this is one way of assessment, right? So we are taking the number of hours of students prepared and marks. So these are different data analysis that we can do, right? Social and behavioral skills. These also plays very important role. Like we have different social networking websites. So nowadays, uh, for student recruitment, what we generally do. So we have certain websites like Naukri. So what we do, we post our CV. Okay. Now there are certain websites that are developed which analyze the behavior of a candidate. Like what are the different posts you are doing in your social networking websites, or what are you liking? Okay, so what are you posting? All these details will reflect your social and behavioral skills. So that is one type of assessment. Along with that, as I said, the suicidal tendencies in students. Suicidal tendencies in students. So what could be the reason? Like maybe marks, right? We don't know. Like we have marks, getting less marks, or maybe students, one student bullying other students, right? So there could be any reason. There could be any reason. So the students are so viable in a stage where they can be offended by anything. Okay. So we have certain studies there where we are been looking into the social and behavior skills of all the students. So that could be one way of analyzing these people. So here we use data science. In the same way, when it comes to behavioral skills, so we concentrate on skills, right? So what are the different skills? Okay, what are the different skills students have? Okay, so we are going to analyze this data based on this. Okay, based on the skills okay students have, we are going to suggest the career. Right? So these are several things that are possible when we have the data science in education field. So when the students are in early stage only, recognizing their skills, what are their skills, what are they capable of, all these things can be analyzed by the teachers or trainers or professors, and encouraging them in the similar field. Maybe like parents' role in children's growth and development, right? So there are certain studies that were made where they have surveyed the parents, okay? So about the growth, right? So what are they looking into? So what are the TV shows they will be looking into? So how many hours they are going to prepare? Okay, how many hours they are going to prepare for their classes, right? So how are they active or not? So are they into any sport or not, right? So these things will help in the growth and development of the children. So this should happen. This should come both from the parental stage as well as the institutions, universities, schools, training institutes. So these are the different surveys that will be analyzed, that could be analyzed and can be used in children's growth and development. So we can create a model, we can prescribe several things by using this data. So these are certain things that are very important. Okay, so most of these things that we are seeing here, these are used in the suicidal tendency project. So we have seen that there are a lot of suicides that are happening all over the country, right? So we have taken a very small data after uh, COVID-19 effect. So the 2 years after COVID-19 effect, and we try to take the data from different newspapers. We had certain reasons there. Okay, so we have tried to capture those reasons, and based on the counting, okay, based on the counting, so most repeated reason that we have taken. So we have given a ranking to that, right? So using these words, we have taken like 30 to 40 important words, and each and every word was taken to create a question. So we try to get answer from each and every student. That is the project, that the main motto of the project is to create an app so that each and every student opens up and gives his answer. And if there is any 1% of students who have this tendency and we can help them, that could be a very good achievement, right? So these things we can do by using data science in education. And maintaining the curriculum, right? So we have discussed about learning management systems, right? We have learning management systems, right? So we are using learning management systems which will have complete study material. Okay, so we can track a student's behavior, how he is reacting to the classes, and we can track attendance, right? So we can create a artificial model such as AI tutor, so which is being created by 360DigiTMG. So where we are trying to capture the behavioral changes, okay, of a student, and we try to give these details to the student. Is he happy? Okay, is he sad? Or any other features that are noticed by the tool that we have provided. So we are trying to provide all the study materials here, student behavior we are trying to catch, attendance we are capturing by using LMS. Okay? So LMS, okay, the learning management system in online engagements, it is playing a very important role, a major role. We can say that it is playing a very major role, and we are nowadays using a lot of, okay, and this is maintaining the curriculum also, right? So now we have a old curriculum, so we have to make changes, right? So we are getting this data, we are analyzing the text. Okay, so we are using data science in maintaining the curriculum also, and along with students, the instructor, okay, we try to process instructor performance also, right? So we try to process the instructor performance also. So like how he is teaching, so his teaching capabilities, right? So is he responding to the students, or maybe his behavior, right? So all these aspects can be studied by using data science. So we are going to get the data. So we are going to do a survey, right? A feedback can be used to analyze and study. The same way students demographics, there are many things like location, right? Race, economical status, or maybe hobbies, right? Gender, all these play an important role. Okay, so we can take all these details. Based on that, we can create a model that could help a student. Right? So there are many different things that we can perform by using data. So like student assessment data we can take and we can analyze, and social and behavioral skills that we can study. Parents' role in children's growth and development. So that is one study we can. Maintaining the curriculum, instructor performance, students demographics, all these are different ways, okay, different ways how we can use the data for analyzing and providing valuable previews, okay, to the education analytics. So to understand better, okay, to understand better the machine learning process, so there are two types of learning that we have. So when it comes to model building, when it comes to model building, there are two types. So basically the model building is nothing but data mining. So data mining is extraction of information. Extraction of information. So what do we do in general? So the trends or patterns which we get are the insights that we use to develop a machine learning model. So what we do here, when we have a raw data, so when we have a raw data here, I cannot use raw data for model building. So first we have to pre-process the data. First we have to pre-process the data. Then we use this data for model building. So in this process, first we analyze the data. So what do we have in data here? So when we have data, so data contains information. Right? So data contains information. How do we get this information? Right? So how do we get this information out? So what do we do? So we measure data. So we measure data. How do we measure data? So what are the different things that we have to measure data? So the data is nothing but the information. Okay. So we are going to measure this information here. So what are we going to get here? If you have, so if you want to measure the information, so we are going to use the mathematical operations, or we are going to use statistical things. So the measurement of the data and looking into these, okay, looking into statistical measures. So this is nothing but this analysis is called as ED, exploratory data analysis. Okay, so we'll be looking into EDA part. Okay, next. So, what do we have here? From this data, okay, from this analysis, from this measurement, what we are going to do here. So basically, when I have some data, from this data, I am going to measure data. So after measuring data, I am going to analyze the data. After analyzing data, by using this analysis, I am going to work on model building. Okay, once I build this model, so we have to optimize this model. Okay, once we optimize, this will be used for final deployment. So these are the different stages. So now we are looking into the model building part. So we have to analyze the data and we have to come to model building part. So once we come to model building part here, in model building, we have unsupervised learning and supervised learning. So what is unsupervised learning? So when I have a data, okay, so generally when I have data, I am going to have the input values and output values. So this is general structure of data. I'm going to have an input data and output data. So for example, if I am looking into a heart patient, okay, if I am looking into a heart patient or heart disease, okay, so I am going to collect all these data, and based on this data, I am going to predict whether the person is going to have the heart disease or not. So this is some general perception. But in the same way, I can also have data where I have only input values. I do not have any output values, right? So this type of data is called as unlabeled data, right? Unlabeled data. What is the label here? Label is nothing but the output variable, the y. Okay, so when we have the output variable, it is also called as label, or it is also called as target, or it is also called as dependent variable. So these are different names of output. So when it comes to the unsupervised learning model, we do not have any output. We have only input. So what we are going to do here? So here in this case, we are going to take the training data, some data, okay, some data we are going to get. So that is my historical data we are going to use. And using this historical data, I am going to feed this data into a machine learning model. The model could be many different models we have. Okay, when it comes to unsupervised. So depending on the data, what is the analysis we are doing, what is the prediction we are doing, based on that we have different data. So using this data, we are going to work on rules and patterns. Okay, we are going to try to capture the rules and patterns in the data. Right? We try to capture the rules and patterns in the data. So using these rules and patterns, we come up with different many different insights, and we use these insights for creating different products. Okay, so this is the analysis that we get, and the part that we are going to look into is the data that we are taking here, which does not have any output variable. We have an input variable. So in the same way, so ultimately what we do here, so we are going to do some certain prediction here. So I have a new data. When I have a new data, so I have to predict. Okay, so by using these rules and patterns, we are going to predict the outcome. So this is the flow chart that we have, where we look into unsupervised learning. So the next learning that we have is supervised learning. Okay, machine learning model that we look into is supervised learning. So supervised learning is called as predictive modeling. We also call it as predictive modeling. So what do we have here? So here I am going to have a training and validation data set. So when I have the training and validation data set, so basically we have the historical data. From this historical data, we are going to take a random sample, and by using this random sample, okay, we will be working on. So we are going to split the data. Okay, we are going to split the data into training data set and validation data set. So when it comes to training data set, we use training data set for training a machine learning model. The model could be anything. We'll be looking at different machine learning models. So we use the training data set to train a machine learning model. And the rest of the data, if we take like the training data set is 80% we have, and the testing data set, okay, the validation data set I am taking 20%. So first I am going to apply the data. Okay, apply the data on my machine learning model. And if I am getting something around like if I am getting a 90% of accuracy when I am evaluating it. So next, what I'm going to do, I'm going to use the validation data. So in case of validation data set, we have certain parameters like we call hyperparameter tuning. So I am going to use the same model that I have used earlier. Right? So the model that I have used for the training data set, I am going to use this same model, and I am going to tune the hyperparameters. So now I am going to see if I can increase the accuracy here. So basically I am getting 90% accuracy here. So I am going to look into if I can get around something like 95%. Right? So this is one way of increasing the performance of a model. So I have tested it Okay, now I have tested it again. Okay, this model. So here I have got 90%, here I have got 95%. Now I am going to combine all this data and again I am going to test on this one where I have tuned the hyperparameters. So now I start the prediction and validation. So now we have a model validation. Now this is the model. Okay, so we have to evaluate this model. So what we are trying to do here, mathematical equation. So we will be looking into this is the base equation that we have. Okay, y is equal to f of x, right? So what happens here? I am trying to find the relation between y and x here. Right? I am trying to find the relation between y and x. What is y here? What is here? Y is output. Right? So I am looking into this is my input. So relation between my output and input, that is something we are trying to look. Yeah. So now this is my test data. So the test data is completely a new data that we are going to use. So it is a completely a new data that we have here. So we are using new data set, and based on the new data set, we are going to apply on the same model. Okay, the best model that we have collected here, we are going to take the best model and we are going to apply. So now this is the flow chart that we have for supervised learning. So basically, if I have more data, so what we are going to take, I am going to split the data into three parts. So one is training data set, the second is validation data set, and the other is test data set. Right? So training data set, validation data set, test set. So how we are going to take this? So maybe training data set, we are going to use 60% of data. And for test validation, I am going to give 20%. And test, I am going to give 20%. So always test data set is completely a new data. So this is how we build a supervised learning model. So why do we do data split? So what happens? We are trying to build a generalized model. We are trying to build a generalized model. So what is a generalized model? Okay. So if I am building a data, okay, if I am building a model on my training data set, so if it is working good, okay, but if the model should be working on my testing data also. Tomorrow when I give this model and we build a mobile application or a web application, so there I am going to get new data, complete new data. So we should be working on that data, right? So that is something important that we have to look into. So what do we have? Okay, when I have training data, so we keep validating and keep retraining the model until desired accuracy is achieved. So that is something important. So when I'm building the model, we keep validating and keep retraining the model until a desired accuracy is achieved. And when it comes to validation, okay, when we are working on validation data, certain points that we have to remember, like test on validation data to get validation error or accuracy. So the accuracy or error that we are getting here is called as validation error or accuracy. So what we are going to do here, right? So we will be working on fine tuning the model parameters to get the better accuracy. So I am going to pick the best performing algorithm that I am going to use for my model final deployment. So this is one way. So still I am getting low accuracy. Okay, basically I have got something like 80% accuracy and still I am getting less accuracy. So what we have to do? So there is no other go. We have to change the model, right? So this will be up. This is something common in any domain that we are seeing here. It could be data coming from a banking domain, or it could be something from manufacturing domain or airlines, anything, any data that we are getting here. So these steps that we are looking into, these are saved. If I have a output data, I'm going to use supervised learning. If I do not have output data, I'm going to use supervised. So we are looking into when it comes to training data. When it comes to training data, and that is something related to validation data. So what is testing data? Okay. So what we are going to do now, we are going to combine the training and validation data to run the model which has given the desired results based on a set of finalized model parameters. So the fine-tuned parameters that we have got, so that we are going to take and we are going to run the final model. Then test the model on testing data. Also ensure that model neither overfits nor underfits. Right? These are certain things that are very important. Okay. And when it comes to testing, so test on testing data to get the error or accuracy, also called as generalization error. Check for model overfitting or underfitting. Run multiple trials and take majority. So these are certain things that we have to remember. So when we split the data, so data splitting happens randomly. Okay, there will be certain function that we are going to use. So the randomization will be done. Okay, will be applied on the data when we divide the data into training data, validation data, and testing data. Okay, so these are certain things that we have to remember when we work on data split. Okay. Okay, friends. We have certain different points we have to cover. Okay. We'll be covering these topics tomorrow. Thank you, friends. Have a great day.